All right, so here go the answers to your weekend homework, and try to keep this as organized as I can. And then most of this stuff, if you have questions about it, you can actually figure out on your calculator. But we're going to go through each one of them. So for each one of these, you're supposed to describe its domain and its range, its intercepts, both x and y, where the function is increasing or decreasing. So remember, these ones will always be increasing or decreasing. Hold on, it's the office. Okay. So these ones will always be either always increasing or always decreasing, and then where they are positive or negative, and then the end behavior. So for this first one here, our graph should have, this is your y-axis, this is your x-axis. We know that this is going to shift this 2 units to the left, but because there's nothing added or subtracted on the end there, it's not going to move it up or down. So this function's going to begin right here and is going to look roughly like that. So you use that to answer some questions here, as well as some math to justify some work there. So for your domain, you should have got that x is greater than or equal to -2. And again, that's because this piece has to be positive. So you should have set x plus 2 greater than or equal to 0, solved that equation. And then the range, so that's your domain. Then the range begins when you evaluate this at the starting value of your domain. So if I were to evaluate f of -2, I get 0. So our range here is that f of x is going to be greater than or equal to 0. So that's our range. Then for our x-intercept, you can get by taking your equation, setting it equal to 0, solving that radical function. So for the x-intercept, we should have gotten -2, 0. We also know that based on the rough sketch of our graph. For our y-intercept, you needed to set x equal to 0. So your y-intercept, when you set x equal to 0, is 0, comma, root 2. You shouldn't simplify that because it doesn't simplify to anything nicely. But again, if you change y equal to 0, that's what you get. So this function is increasing. And it's increasing from when x is greater than or equal to -2 onwards. That's the entire function. It is decreasing nowhere because they either always increase or decrease. So it's decreasing nowhere. And then it is positive when x is greater than or equal to -2, and it's negative nowhere. And then as f of x, so we would say that for end behavior, we'd say that as x increases, f of x approaches infinity. And then we would say as x decreases, f of x doesn't exist. So that should be number 1 there. I think I hit all of those pieces. Now we're going to look at number 2. So number 2, nothing under the radical, so this one should be oriented at the origin. But we do have that -2 on the outside, so that's going to do 2 things. You're going to have a vertical stretch, and it's going to be a reflection over the x-axis. So when you created your rough graph here, you should have had your function starting right there, kind of going like that. I guess it should look more extreme than the one I graphed before, but there you go. So for this one, you are going to get a domain that tells us that x is going to be greater than or equal to 0. We're going to get a range that tells us that g of x, which is the same thing as y here, needs to be less than or equal to 0. So that's your domain and your range. Your x-intercept here is going to be 0, 0. Your y-intercept here is also going to be 0, 0. Then when you're looking at this one is increasing nowhere. and it is decreasing when x is greater than or equal to 0, right? And then this one is positive nowhere. And it is negative when x is greater than or equal to 0. Then we know that as x increases, g of x approaches negative infinity. And as x decreases, g of x does not exist. So that's number 2 there. And now we're going to go on to number 3 and number 4. These ones are more complicated. So for number 3 here, a couple things are happening. We know that this is shifting our function 2 units to the right. We know this is shifting our function up 4, and this is going to give us a vertical stretch because that's a number greater than 1. So for number 3, you ended up with the rough graph of your function looking like that. And this point right here is 2, 4. So that's what your graph looked like there. And then let's go ahead and get into our information here. So on this problem, our domain should have been that x was greater than or equal to 2. Your range should have been that f of x, which is the same thing as y, has to be greater than or equal to 4. And that makes sense because the starting point of this function is here at 2, 4, so it doesn't exist in any of this x space, and it doesn't exist in any of this y space. So then we go into our x-intercept and our y-intercept. Well, if you went to try to set each one of these equal to 0, you actually get complex numbers for each of them. You end up with negative pieces where you're not allowed to have them. So you're going to have no x-intercept here. And you're also going to have no y-intercept. So again, if you want to solve those mathematically, you set x equal to 0 to find your y-intercept. You set y equal to 0 to find your x-intercept. The minute you move that over there, you get a negative number. And then you're telling me that some square root is going to give you a negative number. Well, that's not possible. So again, if you go into these and you actually solve them mathematically, you'll figure out that there's no x-intercept, no y-intercept. This function is increasing when x is greater than or equal to 2, and it is decreasing nowhere. And this function is positive when x is greater than or equal to 2, and it's negative nowhere. And then finally, we would say as x increases, f of x approaches infinity, and as x decreases, f of x does not exist. So that's your end behavior. So I think I've talked about all the parts of 3, and then let's go ahead and talk about 4. So when you're looking at 4 here, the way that you need to think about this is a negative 2 attached to an x. So what that's going to do is create a vertical stretch. You have a negative on the inside, which should be a reflection over the y-axis. You also have a negative on the outside, which should be a reflection over the x-axis. And then you have a plus 1 here, so that's going to make that go up 1. So let's see what happens when we go to graph this one. So on this one, you end up with a graph that looks like this. Oh no. So it looks like that. And this right here is an x value of 1/2 and a y value of 1. So that's your starting point there. And so when I go to look at my domain here, I know that my domain is that x has to be less than or equal to 1/2. I know that my range has to be that k of x, which in this case is y, k of x has to be less than or equal to 1. Then when I go to solve for my x-intercept, I set y equal to 0. And ultimately, when I go to set that radical, I get that my x-intercept is 0, 0. And when I set x equal to 0 to find my y-intercept, I end up getting that my y-intercept is also 0. So that is also going to be at 0, 0. And then when I think about the behavior of my function, it is, my function is increasing because we read it from the left to the right. So my function is increasing when x is less than 1/2, and it's decreasing nowhere. Now, things are a little different here because this one is positive for a very short amount of time. This one is positive when x is greater than or equal to 0, but less than or equal to 1/2, because for that very short amount of time it's positive. But then it's negative when x is less than 0. So I hope you got that part, that one's both positive and negative. And then as x increases here, f of x, k of x does not exist. And as x decreases here, k of x approaches negative infinity. So those are those graphs, those manipulations, those key features of those graphs. So if you have questions about any of those, you can reach out. So for these ones here, we're supposed to reflect it. We're supposed to write an equation that would allow this to happen. So manipulation of this parent function. So I would want to say that f of x is equal to a reflection across the y-axis is a negative on the inside, right? So if I want to create a reflection across the y-axis here, I would have a negative on the inside with my x. Then if I want to translate it 3 units left, I'm going to put plus 3. And then if I want it to go 4 units up, I'm going to put plus 4 there. All right, so back up here, something did happen that I thought happened, but I just wanted to verify that that was true before I went and corrected it. So yes, typically translating to the left is a plus here, but because we've negated this x value to do the reflection across the y-axis, this then is also going to shift to change signs. So again, if you have to negate this value in order to shift to the left, then this actually does become negative because adding in a reflection there shifts both signs. So this is actually, because it would be, the reflection would be distributed out, so that's why that sign changes. So this is actually negative x minus 3 plus 4, and that's going to shift that. So when you go to create your graph, you want to graph that, you sure did get something that has been reflected across the y-axis, and it has gone over 3 and up 4 as it then goes like this, and this is the point negative 3, positive 4. So that should have been that graph there. And then if you watch the video for the notes, we turned this one into f of x was equal to the square root of 2x minus 3 minus 1. So what that should have done there is created a vertical stretch here. This should have shifted it 3 units to the right, and then it should have gone down 1 here. So again, that should have shifted it 3 units to the right because that's embedded. So you should have gotten something that is shifted here somewhere to the right and then down 1. So it should be looking something like that. And just this part here, this value right here is 1.5. So that would be 3/2 comma negative 1. And that makes sense because if you set this radical piece equal to 0, that piece needs to stay positive. So you would set 2x minus 3 greater than or equal to 0. That would give us that x has to be greater than or equal to 3/2 in this problem. So that's where that begins. And then if you evaluate that at the value of 3/2, you get negative 1. So that's your starting point there on that function. So that's it for now. Go ahead and grab your, there's some notes linked in this Canvas module that you'll need for Walsh Lesson 3.6, which is completely different than anything else here. I'm actually not entirely certain why it's part of this unit, but it is where it is. So there you go. So go ahead and grab those notes. You'll also need your Walsh books. So grab those things and get yourself ready for today's lesson.